All right, we are starting the notes for 5.3, which is the sum and difference identity for cosine. So this first little bit is just to kind of explain to you something that if you really stopped and thought about it, you would know, but if I don't say it, you'll make this mistake. So whenever we see the word cosine, it is always followed by something right here. It's an angle measurement, but sometimes it's cosine theta. Sometimes they write it as cosine x or cosine alpha. There is always something that follows the word cosine right here. If we know what the angle measure is, then it would actually be cosine of, pi over 2 or cosine of 60. There's always going to be something that follows the word cosine. As a matter of fact, if you hit cosine on your calculator, and actually I'll do it real quick because I have my Webbit calculator on here. There's Webbit. If I hit cosine, well, got to turn it on. Let me clear all this. If I hit cosine, automatically a parentheses comes up because the calculator is reminding me by putting that parentheses that something has to follow the word cosine. And it's always a single angle measurement. So if I see something that looks like this, cosine A plus B, I cannot distribute the cosine. That is not a possibility because A plus B represents one single angle measurement. So it doesn't work that way. So instead, we have to use an identity. Now, in the book, they go through this long process of explaining how they get the identity. At this point, I don't think that that is all that important. So I am just going to give you the identity. There is the cosine sum identity and the cosine difference identity. So let me point out a couple of things to you so that you, because we are also going to do the sum and difference identity for sine, and they are similar. So let me point out the things that will help you keep them separated. If it is the sum identity, so there's a plus between the two values at the front of the problem, then it's going to be a minus on the right-hand side. So on the other side. So it's a plus on one side and a minus on the other. And you'll notice the reverse. It's a minus and a plus. That's always the case. And with cosine, it's cosine, cosine, then sine, sine. Cosine, cosine, then sine, sine. And order does matter because in this case, it's subtraction. So order does matter. So this is a new identity that we are going to be using. So let's scroll down and we're going to do the first example of how to use this particular identity. Let me back this up a little bit so I have a little bit more room. All right, so the first thing it says is find the exact value of each expression. So when they say exact value, they do not mean put it in your calculator and get a decimal. They mean get values off of the unit circle. Well, 15 isn't one of the ones I learned. I know 30, 60, 90. I know all of those values, but I don't know 15. But that's okay, because if I think about the ones that I do know, I could come up with 15. So I know 45 and I know 30. So I can do cosine of 45 minus 30 because that would give me cosine 15. And now I'm going to use my identity. So let's scroll back up and look at it because I'm sure you haven't memorized it yet. There it is. And I'm going to write this as cosine. We're going to call this is A, and this is B. So when I go to write this out, I'm going to do cosine 45, cosine 30, plus sine 45, sine 30. And now those are exact values that I actually know. So I can go and plug in the values, cosine of 45. So if you don't remember, if you need to relearn the left-hand trick, I'll say this, now that our tests are being given the way they're giving, it wouldn't hurt for you to actually have a unit circle with you, but you would probably be faster if you've actually learned some of these. So the 45s are easy because it's always square root 2 over 2, and these are all in quadrant 1. So 45 cosine of 45 is square root 2 over 2. Cosine of 30 is square root 3 over 2 plus square root 2 over 2 sine of 45. And sine of 30 is 1/2. And I can just simplify that. That's going to be square root 6 over 4 plus square root 2 over 4. And there's nothing I can do with these top values, but the bottom happens to be a common denominator. So I can just add straight across. And it's going to end up being just the square root of 6 plus the square root of 2. You cannot add those two things together because they are not like terms. So that's the answer to A. So that's one that happens to be in radians. And let's do one that is in, I'm sorry, that one happens to be in degrees. Let's do one that's in radians. I'm sorry, I was trying to move this at the same time. So, all right, let me see if I can get a new page here. Well, we'll just move that onto the next page too. This is all a new ball game using the draw function on Microsoft. Okay, so cosine of 5 pi over 12. So this is a little bit harder. You got to have a good knowledge of fractions, and I know that's why you guys don't like these. Because you don't like fractions. All right, so I am looking for cosine of 5 pi over 12. So I don't know the pi over 12s, so I have to think about the things that I do know. I do know pi over 4. I do know pi over 6, and I know pi over 3, all of which could get me to 12. So let's just rewrite these with a denominator of 12 and see if that helps. So pi over 4 with a denominator of 12 would be 3 pi over 12. This would be 2 pi over 12. Ah, well, that's all I need right there. I can do those two because 3 plus 2 is 5. So that's what I'm going to do. I'm going to change this to cosine 3 pi 12 plus 2 pi 12. And I'm going to use my identity to rewrite that. So again, if you remember, this is our A piece, and this is B, and this time it's a plus. So when I rewrite it, my equation is going to have a minus in it. So cosine of A, which is pi over 4, because it's the 3 pi over 12, so it's a pi over 4 piece. Cosine B minus sine pi over 4. Sine pi 6. And now I can plug in the exact values that I happen to know. So again, cosine of pi over 4 is square root 2 over 2. Sine of pi over 6, or sorry, cosine of pi over 6 is 1/2 minus sine of pi over 4, square root 2 over 2. And sine of pi 6 is square root 3 over 2. Ends up looking a lot like the one above it. Got square root 2 over 4 minus square root 6 over 4, which simplifies to square root 2 minus square root 6 all over 4. And that can't be simplified because remember, you can't do inside pieces and outside pieces. So even though they're all divisible by 2, it doesn't matter because these are inside the house. So you can't simplify them with the ones that are outside. All right, so let's look at C. So in this case, I'm going to actually put it back together. And you know what? I'm going to do this one up here because I actually think it'll be a little bit easier just to do this one right here because it's not very long, pretty simple. All right, so in this case, they've written it out, but I can simplify this, and it's a minus, which means I could rewrite this as cosine 87 plus 93, which gives me cosine of 180 degrees. And if I look at the coordinate grid, that would be right here. And cosine is the x value, so it's going to equal -1, because the ordered pair here would be -1, 0. So that's it.